Let's have a look at how aligners adaptation makes a difference in force delivery, especially using 3D printed polymers instead of thermoformed plastic. So we use a lower dental model, fairly well aligned dentition, but despite the alignment that is pretty good, you can see immediately that there are some areas that are exposed to the polymers or to the aligners if we can take advantage of these. These are two examples. And obviously the force being perpendicular to the pressure area, you will get immediately a good force applied to the canines. As an example, these embrasures are present and they can be used again. You can have some here. You can have the same one I showed before. You can have this. It's pretty evident that if you have crowding, these areas will be able to be engaged if the polymers are soft enough and can deliver the right amount of force. When we print the aligner, and I show this as a wireframe, you can see that the adaptation of the aligner, if it's 3D printed directly, such as DPA from Lux Creo as an example, you have all these areas that can be utilized to apply forces. You can also, using direct printing, unlike thermoformed, you can also vary the thickness of the aligner with the software, depending on what you want to do. You can even create, this one would be a void. And you could theoretically, if you had the software, make the aligner thicker to apply more force or to create a virtual power ridge. Unlike the thermoform, when you look at the same model with thermoformed, the undercut software is designed to block the undercuts because the thermoform material is fairly rigid and does not really engage well the undercuts, removing a lot of the possibilities to create surfaces where forces can be applied. We are filling the embrasures. Every single software will do it differently and to a different level, but it's just an example. But immediately you can see that the thermoformed is not really engaging the embrasures and has a very limited capacity to put pressure on areas that it cannot reach. We have to put a significant amount of attachments where you can apply a force to it. Because it doesn't fill, you will leave a lot of these areas, like I showed before, not engaged with the aligner, which reduces the accuracy of the treatment. Thermoformed aligners, while pretty efficient if you add attachments, become not as efficient if you do not add attachments, and why 3D printed aligners have the capacity, by engaging these undercuts, get a lot more accurate adaptation to the dentition and can take advantage of surfaces that are not accessible to thermoform aligners. The aligners now thermoform have not engaged the undercuts, and this is also due to the stiffness. So depending on which type of thermoform aligner material you'll be using, you will be able to either engage a little bit more or a little bit less. And as I said in conclusion, unlike 3D printed aligners, many of the surfaces you would love to use to put pressure on the dentition are off limit of the thermoformed and will not be used, unlike the 3D printed aligner material that has this capacity, which will dispense much more predictable forces and better tooth control.